Everybody, this is our first physical meeting of the GreeNest project. I would like to ask our hosts to make a short presentation about NBL, the Natural Building Materials Laboratory of the School of Architecture of the Technical University of Berlin. And thank you very much again, once more, for all the organization.
Welcome also from us. We're very happy to have you all here today.
So we just will start to show you a little bit about the Natural Building Lab. So we are a design chair here at the Institute of Architecture. And we are working since 5-6 years now here at TU Berlin. And then kannst du eigentlich schon auf die nächste gehen. So that's our mission statement, let's say. And for us, very important is to have collaboration, team working with various networks and work in a transdisciplinary way with society. That's most important to get change done. And for sure, we generate knowledge here and we take care for a good knowledge. And we work with prototypes, as we do with our project as well. And we are always focusing on something what is a post-fossil future, what we will discuss a little bit later as well. Maybe you can also, that's just an overview of our projects we did in the last years.
I mean, we also don't want to steal too much time today, so it's just a really brief overview on what we have been working on in the past. A wild mixture of projects in research, but also in teaching, and we currently also started to supervise or to support some construction projects. One of is the museum building that is part of the of our project, but there's also others, and we always try to incorporate this practical approach in our teaching, in our research, and basically all projects that we do. And this is just a really, maybe more like a collage of insights into our practice, and we're very happy to answer our questions later or also to talk in more detail about some of the projects. And this is maybe the field that we have been working on, trying to find different approaches and formats and methods in our way of working, always trying out new things also. So we're very happy to also continue learning from you and each and every one of you. Thank you.
On the 12th of March this year, the European Parliament approved the recasting, the renewal of the EPPD. This is the energy directive for the buildings. And they decided that from now on, in 2030, new buildings must be zero-emission buildings apart from net zero energy buildings. This practically means that for all the buildings that are going to be constructed after 2030, we should ensure that they request minimum energy for their operation during their lifetime, and this energy should come from renewable energy sources. But furthermore, we should take into account the contribution of the envelope materials or of the construction materials in general in the life cycle environmental impact of these buildings. And in this frame stands our GreeNest project. In this project, we have what we call 16 standardized packages, which are assemblies of technologies that cover from the material to the energy system of a building. And we are combining them in 4 demonstration sites to demonstrate how one can reach new zero-emission buildings. We take this opportunity to start a series of lectures from well-known partners of our consortium. And it is really my pleasure to introduce to you Professor Eike Roswag-Klinge and Professor Andrea Klinge, who are going to give us a lecture today on Bauwende. It's the construction law in Germany, planning and building with planetary boundaries. So Professor Eike Roswag-Klinge, you'll know that he's a professor at the School of Architecture of the TU Berlin, and he's leading the Natural Building Materials Lab. Professorship concentrates on constructive design and climate adaptive solutions, and he's one of the pioneers trying to create architectural solutions that couple natural-based materials with the human aspect, how people perceive it, how people want to use local materials. And Professor Andrea Klinge is a professor at the Fachhochschule Northwest in Schweiz. And she's a professor of circular construction, also specializing on as the title says, on the reuse and potentials of natural-based materials for environmentally friendly and sustainable construction. So I would like to ask them both to take the floor and present to us their without planetary boundaries approach.
Okay. So the Bauwende is a very special topic I will introduce a little bit later, a German topic. And we are looking for something what will fit into our planetary boundaries. That's our main goal. So just very quickly, maybe you can introduce ZRS with a few words.
Yeah, just briefly. Hello, everybody. ZRS was founded nearly 20 years ago. We had our 20th anniversary this year. It's a practice that works, combines architecture and engineering. This was always the starting point with an integrated approach. And at the beginning, we were really trying to implement timber and earthen construction, which was very, very difficult in Germany. So we were working a lot abroad, also carrying out projects in Bangladesh and Pakistan before it was really possible for us to get projects here back in Germany. And our focus is now much wider. We increased our competences. We also have colleagues working on building physics, energy efficiency, fire protection, which is very, very important for us because working with timber, you need to have a good fireproof strategy and so forth, next to our main disciplines, architecture and engineering. And also what you can get from the images, the projects demonstrate a wide variety. We're working on school projects, but also on small-scale renovations. We do also housing projects. So it's quite large, the topics we address. And on one picture, what you can see is the laboratory that Christoph Ziegert established. And this was for us also the opportunity to work on research projects. So it's a fully equipped earthen construction material testing lab that he runs, and where he's also developing the standards for earthen building materials, which is again quite important, and where he also does a lot of testing for manufacturers.
In this field of natural materials, there's very limited knowledge, and we have been lucky to start with H-House and other European projects, and so we are very happy to continue this research towards more circular economy and low-tech with our consortium here. So there's research as well. And we believe ZRS is more like a platform than a business or an office. So we do a lot of support for other teams, etc. So it's more like a network and platform. And we are working with around 70 people there at the moment. So, and most of them doing natural things. It's quite interesting. Yeah, and again, that's NBL. That's what we have seen before. And now our focus, we started with in 2017, and now we started to develop our learning or teaching processes, and now we are also, I think, 10 people around in research, and we are very happy to join this team and also bring in our biggest project we have developed from the school for the research and for and use for the TU Berlin at the end, as the TU Berlin doing an innovation process with this nice pavilion we are working on. So that's our biggest project we are working since years on with plenty of things. So that's the structure of our topics we will discuss with you. What first thing is for sure to reduce our consumption. And then also we'd like to talk about circular economy and circular construction and how we're going to reuse and how we to reduce our footprints of our buildings. And then we also will show a few of our praxis projects we did with ZRS. Actually, we usually shouldn't start with black, even if we are, as architects, very well known to wear dress in black. But the future is every day the clock is ticking, and the problem is getting even worse. So that's today, and we all focus on 2030, 2045, whatever that means. We are discussing mainly carbon and energy, at least, so in our public discussions, and then we have also our discussions in our research projects. And that's something very dramatically, so 1.5 degree reached in Germany the last 12 months. So this is a full year where we are beyond 1.5. So and we are still increasing temperature. So the problem is really, really dramatic. And then Bauwende, that's something what is more political, but also a process, I would say. We would like to change our construction or our manner in building. And in a way, we believe we have to rethink the whole process and the whole approach. And still, I believe we don't have a plan for 2045, like a full plan or a plan into planetary boundaries. Nobody really knows what that means for a specific building, and we didn't break it down. And there's plenty of work to be done. And Bauwende means more like a process. It's not really a defined or certifying system. I think that's a process we will work in for the next 2-3 decades. And as this construction sector has a very long-term relevance, and it takes time to build a house, like 10 years from the first scratch, usually everything what we do today should be design of planetary boundaries, what we couldn't even imagine fully at the moment. So, and if we would think about using the planetary boundaries and stop everything what is not in design of planetary boundaries, I think most of our construction site would stop immediately, because it all is not fitting into our planetary system. And that's why we think there's a very dramatically overhead what we have to think, and then we have to break it down into our everyday practice, into our research, et cetera, et cetera. So there's a lot of work to be done. Actually, we are lucky in European funding. There's quite good money for research, but in Germany, it's very dramatically less what we do research in the construction sector. So we believe we cannot change it, or we don't like to change it, or there's a big industry behind what will not change so much at the moment. So there's a lot to be done. So that's the refuse. Waste is a design error. That's our colleague from, I think where is he from? From Wuppertal Institute. And I think that's very good to imagine that at the moment we are talking about a lot about waste. And most of that demolishing or things which have to be changed are going into waste. And there we have to break down this into a circular construction industry. That's all what we need together. Those numbers, you know, waste is 45% of waste in Germany is construction waste. It's a dramatically number. And what we even don't know so much or don't respect, 92% of our mining, of our mineral resources are going into the construction sector, 92%. I will come back to that number later, and the CO2 emissions, something we know is around 40 to 50%. And our UBA, like the Umweltbundesamt, is the national agency for environment. And they were thinking about something like a planetary model. And there's also parts of it for sure is the construction sector. But the main goals on the left-hand side is we have to reduce our CO2 emissions by 95%. That's something we know all. But as well, in parallel to reach our goals 2045 is to reduce our mining by 60, so wie heißt das nochmal, use of minerals by minus 60%. So we cannot continue consuming our natural resources, and we have to reduce the mining by 60%. That's a dramatically thing to be done. Nobody is really thinking about it, how to get this done. And then we have to link sectors between agriculture, industry, transportation, energy. And also there's one strong pathway is to move into renewable or regrowing materials or bio-based materials. That's one of the central paths our national agency sees for the construction sector. From our perspective, we should, anything what is not connected with the ground, what is not touching wet land, should be done with natural materials in the future, just to get into the model. And we have to reduce anyway the construction what we do at the moment. And then there's one thing, we are through our energy efficiency, we went a lot into mechanical systems, and then we see our prices to build or to construct are really increasing a lot, but we see that our cost for the building shell or for the main raw construction is still, they are still in line with the normal cost development, but we increased by the amount of building technology a lot, so the cost what we increase is coming from the building technology, mostly ventilation systems. And we believe in our pathway, in our thinking at ZRS and NBL that we can reduce, if we use the right materials, a lot. That's something we will also work with the earth flooring and vapor active materials, just to reduce ventilation systems, just to get this curve down, and also to protect these resources, because there's all minerals, copper and other very important minerals. It's just a diagram what we did something like 15 years ago, and it's quite, it's not really changing. Our resources, what is shown through the peak oils, they are now very limited. We have a growing world population, we have limited resources. And still up to 1900 something, we have been designing in line with nature or in line with our climate conditions. Then through the modernism, we had also our fantastic heating and cooling systems and our fantastic glass and concrete and steel. And so then we increased our buildings vertically, and we didn't care any longer about climate. And that's, I think, what we now need to change. We need to adapt our buildings back to natural conditions and also to the boundaries of our planet. And that's a big step, what we have to do very soon. And that's Schmidt-Bleek. He is the founder of the Wuppertal Institute. And he was bringing up this model of factor 10. Factor 10 is for sure also the carbon footprint. Everybody knows we have in Germany around 11 tons. We have to reduce it to 1 ton. And also what is his main focus is we have to reduce the uses of the minerals and natural resources from the ground. And that's, again, looking on the waste production related to the building sector. Here we can see on the right-hand side, that's a construction waste. Here is around 30%. And then the earth and stones related to construction is around 60%. And we have to deal with this topic to change this waste supply chain. So we have to look on supply chains. We have here a photo that's also something what we are doing in our project here in GreeNest. We like to think about the waste chain of waste wood. So that's the whole thing. If we zoom in, we can see we have around 10 million tons of waste timber. it could be furniture, but could be also from construction, etc. And more than 90% goes into thermal use. So it's go into heat plants, and it's wasted and lost resources at the moment. More than 90% goes just into fire, and only a very limited percentage is going into material use, and most of it into chipboards. So they just mill it, and we don't use timber as a timber or a beam as a beam. So all that is kind of wasted, and all you know, like up, I think 5 years ago, still the EU was mentioning that the use as thermal use was something like a recycling, but now that is luckily changed, and we have to rethink this whole supply chains. That's just one example in timber. And that's my most interesting diagram. It's 2 lines that are slightly going down. That is the population in Europe. So there we expect till 2100 that we have something like a reduced number of people by around 10%. That is what Eurostat is expecting. And we have similar dates. For example, for Berlin, we have a slightly growth for the next up to maximum 8, 9, 10 years, and then it goes down. And so we don't need more space. That's what it means at the end for people to live in. And we have to rethink the whole system. We have to reduce, for example, our usage of space. Here, for example, whoever will go up to the 6th floor, where where our offices are, we reduced our office space by 30%. And the Umweltbundesamt, in their strategy, they say we have to reduce our use of flooring for housing from 50 down to 40 square meters. So if you just like to get into planetary boundaries, we have to reduce our consume for housing so from 50 to 40 square meter. That means we need to reduce to 2050 our use of space by minimum 20% or even more. And if you don't have a growing population, that means something like we have a virtual empty space around 20% by 2050. If you think through that model. So for sure, at the end, we don't need any more new space. Maybe in some towns where pressure is big, but for us, it would be better to shift people from here, like an hour away, into Brandenburg, where we have empty flats. And we need just to remanage the whole system, and we reduce our consume. And then we come to reuse, and we never should come into or at the very limited to recycling, to demolish materials as they are, or even burn them or dispose them. So that's rethinking the whole chains. And then our dear friend Daniel Fuhrhopp wrote this nice book, Stop Construction. That means for sure stop new construction, because we have a very dysfunctional existing structures, and we should reuse offices which are now getting to be empty in Berlin into housing. We have to bring back different functions into cities. We have to transform our buildings. We have to make them better related to energy. But the most important thing, we have to use our existing infrastructures. We should never start demolishing. And I think that for us as architects, there's a totally different work, or as the construction sector in whole, as a totally different work, but there's more work than we ever did. So we have to increase our innovation rate from 1 to at least 2 or 3%, and then we just need to adapt to this new work what we have. And then Andrea will take over maybe with reuse of materials.
Okay. I give you a bit of a positive view again, I think, after Eike's introduction, but I think it's always useful to frame our situation a little bit and to understand where we're at. So I'm going to start with a research project that we carried out together with our engineers, where Leon, our colleague from ZRS, was working on as well. It was quite a large project on circular construction that we were starting in 2016. And the idea was really to develop a building on the basis of waste. So we covered all different waste streams that we could think of: mineral waste, but also plastic, which didn't work out as well as we anticipated. We were working also on timber, waste wood, which was quite difficult at the beginning. And we were looking in many different topics, so we try to improve the quality of our waste, because this is a major issue. If you have a better quality, you might be able to integrate more waste into your buildings. And we were developing materials as such, we were developing components and then entire building elements, and on that basis we did a concept for 2 different buildings, one in recycled concrete and the other one in timber, waste wood. Just the design, we couldn't build it in such a large scale, obviously, but the idea was really to have 2 buildings made from waste that were fully dismantleable, so that at the end of the day, if they would, hopefully only after 500 years, not after 50 years, but if you would take them down, you could reuse the different elements that we developed. So proof of concept was done by 2 demonstrators, small scale. One was kept, the other one was dismantled, so that we could really also prove this strategy of dismantling a building. So it worked, but there's still a lot of things to do. We were also looking into design strategies for such circular buildings. Probably pick up just a few things. We need to think about the system itself, the structural system, the lifespan of different components, because we know that, for instance, the supporting structure can last a lot longer than the facade elements. So if you put them into one system and the facade element becomes part of the support structure, it's very difficult to change it. In case you have a change of use, as Eike was describing, for instance, now we have a lot of office buildings that get empty, and if you want to change the facade and it's part of the structural system, in most of the cases, the owner will demolish the entire building. So these are things we try to implement also in the GreeNest projects, such learning curves, but also we will think about material simplicity, that we don't glue things together, that we can dismantle it in a manner that we get the materials separated in the different waste streams. One thing I want to dwell on a little longer, it's the waste wood ordinance that we also have to deal with in the GreeNest project, which is good that we have it, because unfortunately we treated our waste wood with wood preservatives in the past. And this is also one of the main barriers why waste wood is not really used. So normally you need to investigate your timber that you dismantle from a building, and nobody wants to do it, nobody has the time, and it's costly. So we say, or the construction manager says, it's all been treated and then it goes into thermal recovery. And this is what we try to overcome here in the project as well, because we did already investigations. So even if timber has been treated, we are able to cut it away, and we will get then, in a way, virgin material again. So untreated and not harmful to any users. The other thing we try to look at is the cascading use of timber. So here it's the example of a facade element that we haven't really fulfilled in the project overall. So we were working on different sections that we could harvest, and then smaller offcuts that we would use for smaller parts of such a building element. For instance, the larger parts for the studs of this facade element, and then smaller offcuts maybe for the weather shell and so forth. And also there, the idea is that if a stud is not in function any longer, if it has cracks or whatever, that we could take it for the next level, and we could make the weather shell out of it, because it's a much smaller element. So this is just the idea, to bring to use timber in a much longer way, and also to extend the carbon storage that we have. And I know, looking at Daniel, we will discuss this in the project in depth, because we have a different approach in Germany and Europe in comparison to Switzerland, how we calculate the LCA for timber, do we calculate the carbon storage, but we try to implement strategies how to use the timber as long as possible in order to use this carbon sink. This is just a few images to show you what we got from a treated structure. So we had offcuts at the top that we couldn't use because they were treated. We had problems with metal fittings that were not reversible, so we had to cut this out as well. Again, this is why reversible connections become so important. This was our harvest, so the fresh timber that we could use, and then we had these sort of like dust and spans, and we were thinking of that this could also be used for material production. So partners of us, they used at least the chips to create an insulation out of waste wood, which was not achieving the values as the products on the market, but it's a starting point and it's quite promising. So we will sort of like bank on this. We did one prototype for a facade element that we in this project, and I don't want to scare the HOVOG partner, but we want to scale up and we want to construct the entire top floor of the Berlin demo site, one demo site, the Berlin Lodge. So we have done a basic homework already, but there's a lot to be developed within the project, also together with partners like Tahale. So, but this is something we did. So what, in a way, what we achieved is we had the timber from the historic buildings. They were dismantled. We managed to take the material, to work it up, and to bring it back into construction. And this is what we have in a much bigger view here in the GreeNest project, in order to reduce also the resource consumption for timber, because we know that timber is a lot under pressure. Every sector needs to become climate neutral, and so the run onto this carbon storage materials will be much, much higher. Just to give you a brief overview of what we achieved and why it's so important that we think in this way and that we undertake this effort, because it is an effort. It's much easier to extract virgin materials, as we all know, but we have a major impact. So what we achieved in the project is really overall figures. So the integration of 80% of construction and demolition waste. So it depended a little bit on the different components that we were developing and also the different materials. We had a structure that we could completely dismantle, and we were also able to bank on prefabrication, which again in construction is very important. So this is not giving you any disadvantages if you think about waste materials. And then coming to the positive things in terms of the reduction, overall, and I haven't done the calculation, so I'm just reporting here, and Daniel asked me already nasty questions that we will discuss in more detail. But overall, we achieved a reduction on the environmental impact on all the indicators between 38 and 64%. So it's not there where we have to go, but at least is the starting point. We reduced the CO2 emissions by 50%, and the most promising I felt was the cost, because everybody in construction is always looking into cost. We could reduce the dismantling cost by 92% because it was really easy to assemble and to disassemble because of this reversible connections. So this is just what we did in our office in the topic of circular construction, and now I show you a few projects together with Eike again, where we not achieved everything, but where we could start at least implementing our ideas. This again is actually a project that was carried out before, and it's quite nice to see because it's something that we did in the past all the time. So it's a historic peat barn, as it was at the time when the project started. It should have been demolished, and it was clear that this would go into thermal recovery, and thank God one of our friends, he's a builder and a basket weaver, he understood the value of the house, and he undertook the effort to dismantle it because we had carpenter connections, they were only plugged. And he approached us, and we did a design development to integrate a new house into the historic structure because it was open, because it was meant to be used for drying peat, which is not the normal firing system, heating system in Germany any longer. So it was a bit what you do with such a structure. So we did an investigation, and we figured out that the timber was cut in 1810, so by hand. And we discovered through the carpenter science that the building must have been longer and higher. So we expect that the building has been relocated already 2 times. So at the time, material was so valuable, nobody would ever burn it. And it's just our society since 50 years, 70 years, where we have so much machinery that we can easily extract materials, and that the value of material has come down so much. And I think we need to change this again. We need to bring materials back into value in order to take them much longer. What you can see here as well, we integrated a new structure that I show you in a second. And we hope now, from now on, this building has been saved, and we're going to use the structure for hopefully 500 years. So this is, again, the approach. We did a timber construction, high energy efficient, also with the aim to have it fully dismountable. Some of the connectors we used due to cost was also not as good as it could have been. So there's still things to improve, but we achieved already a lot. So this is the dismantling process. As you can imagine, it is easy, but it's also time consuming. I think they took 2 months, but they undertook the effort. Thanks to the carpenter, the reversible connections, it was relatively easy, but still, who's going to invest 2 months in order to take a building down? So again, with our project, we hope that we will have better solutions, and it will be much quicker then, but this is just how it was for this sort of like prototype. The other picture shows that it's important to mark the different building components, that you know where they go. So these are all things we want to think about in the GreeNest project as well, that we consider the full circle. This is then just a few pictures from the new construction site. So we did a floor slab in concrete. It's not possible for the time being because we're touched to the ground. And then we used the historic structure that we brought up, and we integrated again with timber and earthen materials this new structure in order to build the house. The reason why we used earth was in order to bring in some thermal mass, so to protect the building against overheating in summer, which is important, but also to have reversible constructions, because this is a bit difficult to see, but on the right-hand side is an internal partition wall made of earth blocks, and you can dismantle them because you have an earthen mortar that you wetten, and you just rescue all the materials. These are just a few pictures how it looks today. So it's quite a modern approach with, again, white earthen plasters. So earthen plasters don't have to be this eco touch from the 80s. We have very modern products on the market, and I think the combination between the old and the new makes or generates something very special, and it has sort of like patina, and it's giving you very nice spaces, healthy spaces. We don't need mechanical ventilation. It's all naturally ventilated because of this hygroscopic materials. And what's also quite nice, you can see on the timber structures, the repairs that were carried out. Also, some of the parts were not strong enough any longer, but so they were replaced, and we show it so that you can distinguish between the old and the new, and it comes all very nice together. This is how this historic barn looks like. So if you remember the first image, it's a totally different sort of like architectural appearance, and I think this is something we need to imagine as clients, as architects, that we can create something very beautiful out of really old structures. The next project I'm going to show you is quite interesting as well in light of the Plural project that some of you were working on, where we look into refurbishment. This is administration building of the Berlin Tierpark, which was not in use because the building facade was quite not demolished, but the air tightness was not there, and it was really uncomfortable to work in this house. So the client looked into a renovation due to the fact that they didn't have enough money to demolish the building. So this was good for us. Normally it's the other way around. Normally the client has enough money, and this case was not the case. So we came up with a proposal where we actually wanted to keep the historic facade and just to use a simple renovation in timber again, light construction, but we then figured out that we had harmful substances integrated in the facade, and the structural integrity was not given. So we did an analysis and detected that we had a skeleton construction, and we could dismantle the facade without taking the entire structural support system down. So we could keep a lot of resources and only replace the facade. So this is a 3D scan that was carried out, quite precise, because if you work with timber construction, the tolerances are very, very limited. So this worked very well. This is how we approached sort of like the renovation. On the left-hand side, you see a section through the historic building, which was quite innovative for the time. It was a sandwich construction with a rear-ventilated sort of like element, and we replaced it with a modern timber construction with cellulose insulation. Also there, not a lot of ecological impact, and we used the historic connection points again in order to minimize the impact on the dismantling process. So again, these are a few pictures how we approached also the dismantling of the facade. We cut out we cut free the connector points so that we could keep the interior of the building. Also, this was a desire of the client in order to keep the furniture that you will see in a second, but also to minimize the impact and not to take everything out. So one thing, again, we had harmful substances in the floor build-up, but we developed a strategy together with an expert how to keep them inside the building. People are protected, but they have not been taken out in order to minimize the demolition. This is a picture from the construction period, where we changed the facade. And this is then the before and after of one of the larger meeting rooms. So there is no blinky architecture. We kept it really, really simple, but this was really the aim. And we kept all the ceilings due to this approach, and we kept the flooring in the build-up, most of it, only the final layer, the carpet. And more importantly, we kept all the furniture, which was quite valuable to the client. This is how the building looks today. Also, we tried not to do a completely new design for the facade in order to respect the historic appearance of the building. And again, this is how we envisage also potential future changes. We have a skeleton structure that has been rescued. We changed the facade, and this can be done endless time. So we can keep the structure for at least 300 years. And we don't demolish the CO2 that has been emitted due to the construction, but we can keep the building up and running. So again, here what we achieved, sorry, this has not been translated, my mistake. This is a comparison between different scenarios. On the left-hand side, you see the global warming potential, and then on the right-hand side, the primary non-renewable energy demand. And we calculated 3 different scenarios. The one in green is the one that we did. So we calculated only the renovation of the facade. And you see the impact is quite limited. We still have an impact because we have new windows and they have sort of like metal materials. So we can compensate due to the timber facade, but not everything. When we look into different scenarios, the yellow one, the middle one, is a scenario where we say we demolish the entire building and we construct it as it is today. So we have a skeleton structure in concrete and a timber facade. This is quite a common construction nowadays. We have, for instance, for the global warming potential, we have 740 tons of CO2. So this is quite an impact. If we go even for just a concrete construction as a new one, the impact is even higher. And this is how we need to approach such construction projects. We need to get this down. We can't afford to emit 1,000 tons of CO2 for a replacement of a building. Similar figures for the primary energy demand on that is not renewable. So again, we really need to keep our existing structures as long as we can, and we need to renovate with eco-friendly materials in a way that we can reuse also the resources we put in. We also believe that we need to think about what can be done with existing buildings. So this would be a future scenarios section through the building. So we could activate the basement. If we modulate the terrain a little bit, we have decent room heights, so that we could implement a cafe or a workshop. But we could also extend the entire building. We have this, from the structural system, there's load reserves. So we could extend 1 story in timber construction, which means that we could add 2 stories, or we could activate 2 stories without increasing the footprint of a building. So these are just strategies we try to implement in our projects, and we try to work on in order to get where we have to get to. I think you're going to show
2 more projects.
2 more projects.
Okay. Yeah. So what we understood is that if we do a natural-based construction, the foundation is the biggest problem for most of our buildings. So if you put down cellars, or if you put down even car parks or double high car parks, etc., that's increasing the footprint, that's dominating the footprint. So we are looking on our design to avoid basements and do very simple foundations. And then, yeah, that's a lot of future work to be done on foundations, but still at the moment we try to reduce our concrete. But there could be also strategies again. So that's a competition, what we did at ZRS for a school. That's a huge, was heißt das? Skilled workers school with huge workshops, etc. It's a huge cluster school. I don't like to go too much in details. So they have, for sure, on that side, and the footprint, it has to be a 2-story building, and we activated also the rooftop. So that was an additional room program. But the main thing, usually in our competitions at the moment, like 80% of the projects are going to be in timber in the German architectural competitions, because everybody now believes or knows that we have to switch our material approach. And then we thought, okay, what's the next step for an innovative building? And then we found out that this was the existing structure. It's a 1-story shell with a steel construction with light concrete implementations, and it had a foundation with a little basement to do all the dust management, etc., from the carpentry machines, etc. And then we discussed with our civil engineers that we tried to use like everything of the existing structure. So we were thinking of a demolishing process to keep the steel and then the minerals, and then we found out that we can strengthen the foundations because it's point foundations, and we would have to strengthen them a little bit with beams in between and use the existing structure, because then we just need to add a little bit of concrete, and then we can use the whole foundation as it is. And we found out as well that the grid of the foundations was quite similar what we could use for our future buildings. So we went on the exam. So the design criteria was then to go to the same points, to accept that, not to change the shape, and then just add a little bit of concrete to use as much as it is from the existing. And then we added 2 stories of timber construction, and then we brought these steel frames as an additional layer for fire excavation, and also as a scaffolding for doing exhibitions of the works the students do there, etc., and have a green facade system. So we brought in like so around 200. We try to bring as much possible of the resources back into the new construction and design the new building based on the resources of the existing one. And then again, it's only the phase A of LCA, like the erection phase. And then we found out if we do a complete new construction in concrete for this room program, so we would have CO2 emissions of 2,500 tons of CO2. And if we do the building in timber on the existing foundation, so we will have a minus of 2,500 tons of CO2. That's a huge impact to work with existing foundations or to avoid, however we do it, concrete in foundations. So that's what we learned from that. Unfortunately, the competition, so it was only the second prize, and that was not written as a eco-innovation process, so they were focusing just on timber. And so we have not been able to go into that strategy, that structure. But that's showing the impact of if you just change your design approach. I think that's what we need to learn. We need to just to think different. And then we can use much of resources we have. And then a very small, very experimental thing what we did in our first year here. This is like a small pavilion. So this was in 2017 when we started here. And there is an area here in Neukölln. If you stay longer, that would be nice to go there. There's Kindle Areal, so there are many social projects going on in that old brewery area. And we just told them to build something like a demo building from 3 by 3 meters and to keep it for 1 year and use any resource you will find. And then they started designing, and for sure what happens to architects, if you don't limit them, they grow. So at the end, we have been building a 10 by 8 structure. And we learned that if we are investigating resources first, and if we're starting design, if we interact with our legal departments, etc., so the whole design process will be more like iterative and will be changed. So it's not a linear process, so it's always a step forward, step back to come to a final solution. So they learned that they have to change their design approach. And then we did a lot of experiments. For example, this was wallpapers or advertisement papers. And then one said, okay, you can put water on it. So it's a reversible glue kind of paper. And the first started to make like belts of it and join things together. And then they tried to make thicker layers with air inside to have an insulated panel or things like that. So they did a lot of experiments. And then another one found out that they have these kind of cardboard boxes for vegetables. So that's a Euronorm box. What we learned from that process, they were the same standard, and she tried to use them as an urban straw bale to construct the first step was to do it like masonry. But then the other students learned that we can use that boxes and glue it with the wallpapers. And so then they have been building up wall elements out of it. And then they designed the process like prefabricated walls based on that module of these vegetable boxes as an implementation into this pavilion. And then at the time we had a very conservative engineer on civil engineering, and they said, okay, we need a timber structure because that walls will be paper and they will fly away. And we said, okay, we will do testing, and then we made a ready-made wall element, and then we put in the wind load, and then after tripling the load, then he accepted, okay, this wall will fit, will hold, and will stand. So we didn't add additional load-bearing materials in timber, so that's the walls are done completely out of paper and reuse. And then they went out to harvest timber materials, and then they measured all these things they found. And based on that, what they found, they went into this small model workshop over here, and then they designed, okay, we have 2 meters or 3 meters here and there between the machines, etc., etc. They were designing the whole process based on the found materials, cleaned them all up, and prepared them for construction. Based on that module, what they find, they designed a grid to have with additional, to add with small pieces of wood into a 5 or 7 layer high grid, and then to extend this one with small elements to a 8 by 10 meter element, what is the main load-bearing structure. And then we have built it with the students on ground, produced that all in the situation in Neukölln, and then we lifted up the whole thing and put it on the stands here. And that's quite, it's a very long and good learning curve, how we, what are the problems you are faced if you use existing material, and we still didn't think about any denorm or anything, but already there was a lot of learning curve how to get this construction done based on that material. So that was the pavilion in his rock construction, and then we added this paper wall thing down below for a couple of years, and then there was a lot of social problems because people start living around it and start fighting, and there's drug things going on at night, etc. So we took out the walls again, so the pavilion is now again still there, and after 5 years still existing. Actually, we just would have had it for 1 year, and still for sure if there's a problem we are connected with, or our students still work in corporations with others there doing workshops under that small social infrastructure. And that's how the things are running here in our lab. And still I think the big pavilion now is learning, and the next step for sure going into a big structure with all the learnings from these very first experimentals. So if we're trying to summarize, again, it's a bit of a nightmare for most of us maybe, what we need to be done in the 20s and 30s to get into something what is planetary boundaries in 2045. We have to avoid new construction. We have to reduce our consume of used space by 20% around, and we have to reduce the raw material extraction. That's the beginning from the Umweltbundesamt. And we have to avoid demolition. So we have to use any infrastructure what is existing, and we have to adapt our uses for that and to adapt our design into that. And then for sure everything what we do has to be in a circular manner. We have to rethink the whole value chains. And then if we just could imagine that most of the infrastructure is existing, concrete is there, and we just change our fit outs and the facades maybe, so then we are reducing our need of resources a lot. And then we have to go into a bioeconomy also for construction sector, and we have to substitute most of the minerals by nachwachsende Rohstoffe, so what means regrowing resources, what could be straw, could be wood, could be hemp. There's also reed and things like that, what are coming up now with the new changes of our landscapes. And there's so much research to be done for the future that we can just go into that process. And what we still believe, if we continue as we do research at the moment, we know we have a problem with the screw, we develop a screw, we go into denorming process, etc. So it takes to bring a screw from the first idea to market at least 8 to 10 years, and then we need another screw. So we don't have the time to continue with this process, what we are doing. So our research approach is not fitting into our problem. So what we believe is that we need real labs, so we need immediate action. So that's what we do now with the pavilion here. We find whatever timber we have, we try to get it into a design and try to have it as a safe construction and bring it into a building what has a lot of legal things against us, what we believe is a scientific surrounding and proof. We can just have this, we have the Sprung innovation, jump innovation, just to leapfrogging into a future. So we had this formula that we said, especially for official buildings, like governmental buildings, they should use 10% of their buildings to make them an innovation leapfrogging projects. Add an additional invest of, let's say, 20%. So that would increase our governmental cost by 2%, what is nothing related, all the things which are increasing prices anyway. And then we could like have a huge leapfrogging and a movement towards a good future, hopefully. And we have to do it for sure with societies, with the people integrated, and learning from people and taking people with us. I think that's a little bit maybe harsh for some or like very tough position, but just we like to start to imagine what could be steps to solve. And then we need to see what steps we can do today or tomorrow to go further. And I'm sure with our project we do a big step for that. Thank you very much.